Hello everybody, today we're going to be talking about composite figures. So this is day 2 of our measurement unit. So it's a little, this unit's kind of broken up into like mini topics like I talked about in class. So this is the second topic. So the first one was Pythagorean theorem. This one is composite figures. So let's go ahead and jump in. Composite figures are irregular shapes that are made up of common figures like triangles, rectangles, squares, trapezoids, circles or half circles, stuff that we know, but as a whole they look like a weird shape. Okay? Area is the amount of space this shape takes up, so the inside part, and perimeter is the length of the sides of the shape, so the outside part. Okay? You will need to find area and perimeter of composite figures, so those irregular things where we don't have a formula for. But we can do it because we can split them up in shapes that we do know. We can find the area and perimeters of the shapes that we know, and then just add them together to find the whole shape. So let's start off with perimeter. We have to find the perimeter of this composite figure. So perimeter, when in doubt, just add up all the sides. That is the common thing for any kind of shape. You just add up all the sides. Okay, some shapes, because they're more common than others, already have a formula with it, which is great, but for these irregular ones, we don't. So in order to find the perimeter, all we have to do is add up all the sides. Unfortunately, we don't have two of the sides. We don't have this one or this one. Okay, so we can't quite add it up, but we can find these two sides fairly easily. So this is what we're going to do. We're going to split it up into two shapes that we know. This guy and this guy. So two rectangles. Okay? So when I split it up though, what happens is that I'm splitting this long side up. Okay? So this long side altogether is 18 feet. But now we have just this side and this side. Well, this side of this rectangle is going to be the same length as this side. So we know that this one is 12 feet. So something plus the 12 feet will give me the 18 feet total. So I have to work backwards. 18 minus 12 gives me 6 feet. So this side, just this part, must be 6 feet long, which means that this side below is also 6 feet. Okay? That's one side that I filled in. Now we need this one. Again, we know that this is 9 feet, so we also know that the one across from it is 9 feet. Altogether, though, it's 12 feet long. So 9 plus whatever this is will give me 12. So I just subtract 12 minus 9. That side is 3 feet. Okay? Because it needs to be the same length as this one. So now that I have my two sides that I didn't for the outside, I can go ahead and add them all up. So I do 9, 18, 12, the 6 feet that I found, the 3 feet that I found, and then 12 that was already given. Just add up all those sides. Your perimeter is 60 feet. Okay? So you kind of have to break it apart and see where you can get things. You could have also broken it this way. It's really what shapes you see and how you want to break it up. Okay? So, example 2, same thing, we need to find the perimeter of this shape. Well, in order to do that, we need this side, which we already have, is 50 feet, and we need these half circle sides. Okay? So we need circumference for half a circle, which means this is the formula for a full circle. So half a circle means that we are going to be doing, oh, where'd it go? It's supposed to be clickable. So half a circle is just dividing everything by 2. So I just get rid of this 2. Half a circle is just pi r. Okay? Now, the diameter for the circle, they're telling me, is 30 meters. So the radius is going to be 15. Okay? So I can plug that stuff in. And for half a circumference, I just multiply this together. I get 47.1 meters. So that means for half that circumference, it's 47.1. And I'm doing it for both because they both have a diameter of 30, so they both have a radius of 15, so they're going to be the same measurement because they're both half circles. So the only thing I'm missing is this side, which because it's parallel to this one for the rectangle, it's also 50. So all I do now is just add them all together, and I get perimeter equals 194.2 meters. Okay? The circle part is going to be the one that's a little different because it's not just like a full shape like we'd like it to be. It's a half shape, so you have to remember to half the formula. Okay, only do half the formula. You could easily find a whole circle and then divide it by 2 at the end. That works too. Or because these are both half circles and they're the same radius, you could just add these two together and it's going to give you the circumference of a full circle, which is great. That's what we need. Okay? So now you're going to try this one on your own. I try to pick one that it's a little bit more familiar to. Okay? So go ahead and give that one a try. You can pause the video or wait until the end. We're going to go ahead and move on to area now. So area of composite figures, I think, is a little bit easier because what you're doing is you're splitting your figure up and you're just finding the area of each figure and then adding them together. So here, these sides, so this is 12, it's the same, it's congruent to the one below it, which means that this side was 6, we already did this, and we split it up. So I'm just doing length times width, 9 times 12 for this rectangle, which gives me 108, and then for this one, I have to use this side that I just found was 6, so I'm doing length times width, 12 times 6, which gives me 72. So the area of the entire thing, I just add these two numbers together. The total area is 108 plus 72, so the total area is 180 square feet. Okay? So just find the area of each shape, and then add them together. So we can do the same thing for example 4, which is that weird, like, basketball. It kind of looks like a basketball court to me. Shape. So remember, the radius is still 15 for this one. So we are looking for half the area of a circle for these two sides. Okay? So a circle is pi r squared. We need half of that, so we're just going to multiply it by 2. Or divide it by 2, however you want to think of it. So I go ahead and plug that in. Where did I do the work for this? I plug it in. I don't even know if I have it. Oh. So half of pi times 15 squared and half of pi times 15 squared will give me the areas for these two halves. Or you can find the area of the whole circle and then divide it by 2. Or because you're doing 2 halves, that makes one whole circle. You can do it that way. The area for the inside, that's a rectangle, so we do length times width, 30 times 50. So for this half of the circle, I get 353.4. The middle, I got 1500. And for the end, I got 353.4. Add them all together, because those are my 3 separate areas. This should say, not P. Let me edit it. It shouldn't say P, it should say A, right? Just want to edit. Ah, annoying. Alright. So, whoa, things are moving. A equals 2,206.8 square meters. Not P. Go away. Delete. Delete. Delete you. This one. Okay, so our area, we just added it all together. So now you're going to try this one on your own. Okay, you kind of have to find the missing sides. Actually, you really don't. It's just nice. So, total area of the floor that needs to be recovered, so there you go. Now, for partial figures, there will be problems where you have to try to figure out the shaded part that's covered, or that you need to deal with, the area of the shaded part. So, the problem with this is that it's not just the entire rectangle. Because we have 2 big circles in here, we have to figure out the area of the whole thing and then subtract these areas from it. Okay? So we're first going to calculate the outer shapes area, the rectangle. So we're just going to do length times width, which means we're doing 21 times 10.5. Okay? It gives us 220.5 square centimeters. Okay? To calculate the non-shaded part, we are finding the area of each circle. So, and we're multiplying it by 2. We're just finding the area of the circles and multiplying it by 2 because they're the same size. So twice the area of a circle. So the area of one circle is 2 pi r, right? Yes? No? I'm trying to think now. The area of one circle. I can't even remember now. Oh goodness. Hold on one second. I'm gonna go look for something. It's gonna take you 1 second for me to figure it out. But it's gonna take me a few seconds, so. Okay, I figured it out. I think. We're gonna find out if I'm right. So, the area of a circle is pi r squared. Yeah. So I multiplied it by 2. I put the 2 in the front because I'm doing it for 2 different circles. Again, you could find the area of one and then add it twice. That works too. Alright, so I found that out. I just typed in the calculator. I ended up getting 137.2 square centimeters. Okay, so now that I know what the total area was and what the area of the non-shaded part is, I can use that to find the area of the shaded part. So what I do is take the total shaded part, the rectangle, and subtract the non-shaded part. So 220.5 minus 173.2 gives me 47.3 square centimeters. That is the area of the shaded part. So these little like corners around the circles, that's the area that takes up. Okay? I gave you a little bit easier one for your try on your own, so you're going to try that. And we will go over these in class. If you're out because of Finance Park, actually, we're going to go over this after Finance Park. In class, during Finance Park, we're just going to do more practice with it. Okay? So if you have questions, you can ask it then, if you're there. If not, I will see you when the whole class is back. Okay? Thanks. Bye. Let me pause it. Bye.